This is lesson 5-4, the final one in this unit. Application of quadratics, day 2. Same goal as yesterday. I need to use all three forms of the quadratic equation to solve problems. So this first example is about a water balloon. It was thrown from the top of a building straight up. The height in feet is h, and the time is its release is t, and then there's our equation over there. So the questions are, how far from the ground was it released? And I think that sounds again like, hopefully, y-intercept. So very simple, 20 is our y-intercept. What is its maximum height? Well, max sounds like vertex, and height is y. So we want the vertex y. Well, let's figure out the vertex x first. So x is opposite of b over 2 times a. So that's just -8 over -4 or 2 seconds to reach its max. And then the y value is, plug it back in, -2 times 2 squared plus 8 times 2 plus 20. So we get -2 times 4 is -8 plus 16 plus 20. That's 36 minus 8, which I believe is 28. That's a really ugly 8. 28 feet. 36 minus 8, 28. So maximum height is 28 feet. How long was it in the air? Well, it's in the air. Well, let's go down to number 4. How long did it take to reach the maximum height? Well, that's x, vertex x, which we figured out already, 2 seconds, okay? Figure out how long it was in the air. That's going to be a 0 of the function. So we're going to have to find out where x-intercepts, where does it hit the ground? So 0 for height. I'm going to factor out a -2, and I'm just going to give that thing a shot and see if it factors. So 10 is 2 times 5, 10 times 1. No, I can't factor it. I'm going to have to use the old QF on this, aren't I? So we've got opposite of b plus or minus b squared minus 4 times a times c over, I'll put -4 down there. So 64. And then 4 times 2 times 20. It's 160, and it switches to plus. So plus 64, and then take the square root, and I get 8, -8, plus or minus 14.97 over -4. Well, if I use the positive 14.97, it's going to be a positive number on top, and I'm dividing by a negative, which is giving me a negative time, and I don't want that one. So I'm going to say -8 minus 14.97, and then divide that by -4, and I get 5.74 seconds. Okay, so how long did it take? How long was it in the air? 5.74 seconds. From its maximum height, how long did it take to reach the ground? Well, it took 2 seconds to get to the maximum height, and it took 5.74 seconds to reach the ground. So I'm just going to subtract. Okay, and you get 3.74 seconds for that. Okay, total height in the air was 5.74, total time in the air, 5.74. And it reached the max at 2, so it took 3.74 to fall back down to the ground. Okay, you guys give this one a try. So shut the video off and start it back up when you're finished. So this one seems like a simple formula, but it's a frog's leap on the moon can be modeled by the equation where x is the horizontal distance and y is the height. So we don't have any time here. This is just horizontal distance and height, so horizontal and vertical. So what's its maximum height? Well, that's vertex, right? So I need the x-coordinate of the vertex first. So I'm going to go with the opposite of b over 2 times negative 0.02. So that's negative 1 over negative 0.04. So 1 divided by 0.04. 1 divided by 0.04. Looks like x is 25 feet. So at 25 feet horizontal, I get my max y vertical. So let's put negative 0.02 times 25 squared plus 25. And that's going to give me y. So 25 squared is 625 times 0.02 negative is negative 12.5. So I get a positive 12.5 feet vertically, or height. Okay. So find its maximum height, 12.5 feet. How far is one leap? Well, here's what I know. If one leap got me to the maximum height, if I'm on the ground and I leap, right, like this, I know that at the peak we were at 25 horizontal feet. So that means for the full jump we'd be at 50. So all I have to do is just double this vertex value of 25 feet horizontally and get 50 feet horizontally for one leap. So when the frog is 35 feet into its leap, what is its height? Well, that's giving you an x and just asking for a y. I just need to plug that x value in and figure out what y is. So y is going to be negative 0.02 times 35 squared plus 35. So 35 squared times 0.02 negative, and so that's going to be 35 minus 24.5, which is 10.5 feet high. And this last question, how much time does it take to do one leap? We can't answer that. This question is not about time in this case. It was height and horizontal distance covered. Okay. Example 2. This is talking about figuring out a value and just describes the number. 2 less than means you're going to subtract 2 from something. The square of a number, well, you're going to subtract it from x squared. So 2 less than means minus 2, and then here's my number, and I'm going to square it, is equal to the same number, which is x, less than 40, which means 40 minus. So I need to move that over so I can put a 40 minus x. The same number less than 40. There it is. So this is a quadratic, and you solve it by moving everything to one side of the equation. Put it in standard form. So plus x and minus 42 equals 0. And I think this factors 6 times 7. Yeah, so x is 6, or x is negative 7. They're both correct. All right, 5 times a number. You try this one. All right, shut it off, then turn it back on. All right, so 5 times a number x, so this is 5 times, and that's x, is, here's that less than again, which means something minus 36. What is it? It's the number squared. So we're going to do 5x equals x squared minus 36. Find the positive solution this time. So 0. Move the 5x to the right, make it negative 5x minus 36. I don't know, can we get lucky twice? Yeah, how about 9 and 4? Oh yeah, negative 9 and positive 4. So the positive solution is the 9. And this solution is negative 4. They don't want that one. It says the positive. Okay. The width of a rectangle is the length minus 5. So let's just write little expressions here for length and width. Okay. So we'll call the length x. And the width then is the length minus 5. And the area is 14 square units. So 14 equals length times width. So area equals length times width, and I just plug in 14 for area, x for length, x minus 5 for width, and I'm going to distribute x squared minus 5x. Move everything to one side of the equation. Factor 7 and 2 positive. Nope. Negative positive. So x is 7. Does it make sense that x is negative 2? Can a length be negative? No, lengths are not negative. So that answer is out, and x is 7, which makes the width 2, 7 minus 5. So you just plug 7 in here, subtract, and you get the width of 2. All right, you guys can try this one. So length, width. The length is 3 more than twice the width. So width is just x, and twice the width increased by 3. That's 3 more than. Determine the dimensions if it has a total area of 27. So again, area equals length times width. So 27 equals 2x plus 3 times x. So 27 equals 2x squared plus 3x. Set it equal to 0. Minus 27. X and 2x. Does it factor? I don't know. Yeah, 9 times 3. How about this? 3, 9. And then that would be positive 9 and negative 3. So the width has to be the 3, because this one gives me a negative answer. Negative 9 halves. That's out. So x is 3. So what do they want? Determine the dimensions. Okay, so length then is 2 times 3, which is 6, plus 3 is 9. So this is a 9 by 3 rectangle. Example 4, this is just a proportion. We're just going to cross multiply. So x times x minus 3 would be x squared minus 3x. And x minus 7 times negative 5 is negative 5x plus 35, and I'm going to move everything to one side of the equation to solve. So adding 5x to negative 3x gives me 2x, and subtracting the 35 and factoring gives me 7 and 5, positive 7, negative 5. So there's two solutions to this proportion, negative 7 and positive 5. You try this one. That is a 4, sorry. So x is either 5 or negative 4. Those are our two answers. Okay. Oh, these are good ones. These are about maximizing. We're going to maximize the area. Okay, so these are maximization questions. All right, so a farmer has 500 feet of fencing. He wants to create 2 sheep pens by dividing a rectangular area in half, as shown in the diagram. So every black line is a piece of fencing. So really, you have 3 pieces of fencing that are X, and you've got 2 feet of fencing that are Y. And I know that he's using all the fencing, so that equals 500 feet of fence. Okay? That's a really sloppy 5. Okay. Now the area formula for that fenced-in area, because we want to maximize the area, is just x times y. That's how you get the area of a rectangle. Just take the length times the width, and those are x and y in this case. So I'm going to solve this first equation for y. So I'm going to keep 2y on this left side, and I'm going to move the 3x to the other side. And then I'm going to divide by 2, and I'm going to get negative, I'll put 1.5, x plus 250. So now I'm going to substitute that expression into the area formula here, and this is what we're going to get. We're going to get area equals x times negative 1.5x plus 250. And by distributing the x, we're going to get our quadratic. Now, maximum area is going to be, oh yeah, I saw that for y. Yeah, what's the width of the fenced-in area? So I'm going to solve this for x. Well, maximum area is vertex. Yeah, so x represents, yeah, so we're going to maximize the area. So we're going to find the vertex of this thing. So the vertex is opposite of b, which is negative 250, divided by 2 times a. Well, 2 times negative 1.5 is negative 3. And if you divide 250 by 3, you're going to get 83.3 for x. And that's going to be the maximum area. Let's see. Let's look at this next slide here. Oh yeah, we want the y value. So when x is 83.3, then we get the maximum y value. Okay? So now let's plug that back in and get y. So we have 1.5 times 83.3 plus 250 times 83.3. Okay? So 83.3 times 1.5, that's roughly 125, negative, and then plus 250 times 83.3 is 20,825. And I'm going to subtract 125 from that, and that gives me my max area. So the maximum area is 20,700 feet squared. Okay? So what did we just do? Well, this next slide shows us what we just did. First thing we did was we made a drawing and labeled the length and the width. So there's my drawing. Okay? Then we wrote a total fencing formula. So this right here, I just added up all the x's and y's to get this total fencing formula. And we set it equal to the total amount of fencing. Well, then we wrote our area formula. Area equals length times width. So that's right here. Area equals x times y in this case. And then we solved the total fencing formula for y. So we took this equation here and we solved it for y. And then we substituted it back into the area formula right here. And then we found the vertex, the x and the y coordinates, where x is the width of the field and y is the maximum area. Okay, so that's what we wanted, was the y value. So we found, using negative b over 2a, our x value, right? Opposite of b is negative 250. 2 times negative 1.5 is negative 3. So when the width is 83.3, that gives me a maximum area of 20,700 by plugging that back into the original equation, getting your y value. Okay, so this is kind of the steps you have to take here. Let's try another one. The farmer has 300 feet of fencing, okay, and wants to create 2 sheep pens attached to a barn by dividing a rectangular area in half as shown. Well, this is a little different because do you have to fence along the barn wall? No, it's silly to put fencing along a barn wall. So you're going to have a piece of fencing here that's x and a piece of fencing here that's x, but there's only one y. We don't need to fence this back side against the barn. So our total fencing formula then is 3x plus y equals 300 feet. So we used all 300 feet of fencing to create those rectangles, okay, to create those areas. So now the area formula is just x times y again. But let's solve this top equation for y. So that's simpler this time. Just subtract 3x. So 300 minus 3x. Then I'm going to substitute that into the area formula. So you're going to plug this right in there. So you get area equals x times 300 minus 3x. Distribute. I don't like writing threes. There we go. 300x minus 3x squared. So I need to find the maximum area, and I need the dimensions. Well, if I find the vertex x coordinate, that's the width of the field. So I'm going to use my negative b over 2a. So b is 300, so negative 300 over 2 times negative 3. So that's 300 divided by 6. Tells me that if I make my field 50, or my sheet pins 50 feet wide, then I'll get a maximum area. And the maximum area is found by plugging this back in. 300 times 50 minus 3 times 50 squared. So 50 squared is 2,500 times 3. So this is negative 7,500. And the other is 300 times 50, which is 15,000. Silly pen. And I subtract 7,500 from that. And so the maximum area to be fenced is 7,500 feet squared, and the dimensions of the field are 50 by, well, look up here. When x is 50, what's y? 3 times 50 plus y equals 300. That's 150 plus y equals 300. Subtract 150. And the length is 150 feet, and the width is 50 feet. So those are the dimensions of the field, and that's the maximum area of the field. Okay? All right, try that assignment there.